Hi guys, today we're going to go through redox reactions. I'm hoping you've seen part 1 and 2 because that's really going to help with your understanding of this lesson. So the clues in the name here for us, both reduction and oxidation happen at the same time in redox reactions, okay? So reduction and oxidation happen at the same time. Okay, now if you remember from part 2, we looked at the example of sulfate reacting with magnesium first to form magnesium sulfate, and then we saw what we called a displacement reaction when calcium was added into the equation. Because calcium's more reactive, calcium took the place of the magnesium. Essentially it displaced it and we form calcium sulfate and magnesium. Now we're going to look into half equations which essentially tell us what is happening to the magnesium and what is happening to the calcium when they react with sulfate, or what's happening in this reaction. So at first, okay, we're just going to go through the charges of magnesium and sulfate. So we know magnesium's in group 2, it forms an Mg2+ ion. We covered that in part 1. We also covered the charge of the sulfate ion, which has a -2 charge. Calcium in this state obviously has no charge, but when it bonds to sulfate, in order to do that, it has to form a positive ion, and it does that by losing 2 electrons to form a calcium 2+ ion. Now one thing you'll recognise is that the charges of our metals change. So calcium changes into an ion and the magnesium ion changes into an atom, but what does not change is the charge on the sulfate. Okay, now we give these type of ions a special name. They're called spectator ions because they remain unchanged throughout the reaction. Okay, sulfate here is SO4 2-, and on the product side is SO4 2-. So as a result of that, we don't need to include them in our half equations. Right, so just a reminder here of our acronym. Oil rig: oxidation is loss of electrons, reduction is gain of electrons. Now let's look at what exactly happened to magnesium. So how did magnesium, the ion, become magnesium atom? So how did it lose that positive charge to having no charge? So here it had a +2 charge, and over here, I don't know if you can see that, that's a 0 charge, right? So the reason it's positive is if we go back to a bit of ionic bonding. Now, a magnesium atom has no charge, right? Because it has a full outer shell. Now, when it becomes an ion, when it reacts, it has to lose 2 electrons to do that. So we know that it already became an ion when it bonded to the sulfate. So we want to know, how did it become an atom again? So over here it had to lose 2 electrons. In order to become an atom again, it had to gain those 2 electrons back. And if we remember, sulfate in the previous example said to the magnesium ion, you know, you can have your electrons back because calcium gives me those electrons quicker. So essentially it would need to gain those 2 electrons back, right? So if we look at our acronym again, well, we call the gain of electrons reduction. So we're going to say that our magnesium ions went from having a charge of +2 to no charge through the addition of 2 electrons, and we call that reduction. So we would say that the magnesium ions have been reduced. Right, if we just move up and look at how did our calcium become an ion. Well, essentially, same thing again. This time our calcium had no charge, okay? And if we go back to our example here, we look at the atom. This is the atom. This is the ion. we know that calcium has 2 electrons in its outer shell. When it reacts, it loses 2 electrons and forms a positive ion. So we call that, the loss of electrons is called oxidation, and we illustrate that using our half equations. Okay, so here the half equation showing that the calcium atom became an ion by losing those 2 electrons. Remember, metals lose electrons to form positive ions. So this is a really good example of half equations, essentially showing how did our ions change their charges. Right, essentially what we can then move on to, because we've got 2 half equations showing oxidation and reduction, we can move on to something called an ionic equation. Okay, so this is a really good definition that we've not covered yet. If you could put that in your notes, ionic equations show the species that have changed, only show the species that have changed. So remember, we're not going to include our spectator ions, so in this case we don't need to include sulfate. So essentially you're just combining the 2 half equations. So I've got the 2 half equations here, the magnesium, the calcium one. Now you'll notice I've got a line through my electrons. Essentially they cancel out on each side, so I don't need to include them in my half equation. So I've just combined the 2 equations, the magnesium ion, so on the reactant side on the left of the arrow, and the products on the right of the arrow without my electrons. Magnesium ion plus calcium, and we see our calcium atom has become an ion and the ions become an atom. Now, bearing in mind, if we remember our definition of a displacement reaction, we're talking about a reaction involving aqueous. If we go back, actually, let's go back to our definition, that a more reactive metal displaces a less reactive metal from an aqueous solution of itself. So we're still going to include our state symbols, essentially just not showing the sulfate. So that's what we call an ionic equation. Okay, you just combine the 2 half equations. Right, what I'd like you to do is, actually we've looked at these 3 equations in the previous lesson. We wrote these out, but now I want you to delve more deeply into them. Show me which species have been oxidized and which have been reduced, and then combine the 2 half equations and write out the ionic equation for all 3 of them. So if you just pause the video now and have a go at 3 of those, I would say give yourself maybe about 10 minutes to do those, and then we'll go through them. Okay, right, let's go through the first one. So a really good trick, or top tip, sorry, would be to just write the charges, the combined charges of each species above, so you can quite easily work out how the charges have changed. So for example, copper sulfate, well, my sulfate is always going to be 2 minus, and therefore we know that this copper would have a 2 plus charge. We know at this stage magnesium has no charge, but when it's combined in a displacement reaction to sulfate, it has a 2 plus charge. My sulfate, remember, doesn't change, and my copper now has no charge. So from this, I can firstly, let's do copper first. So copper Cu2 plus, and I want to show how did it become Cu with no charge. So how did it go from that to that? Well, at this stage it is an ion, because in order to become this, it lost 2 electrons, and so in order to become an atom again, it has to gain those 2 electrons back, and so we called this reduction. If we do the same now for magnesium, so magnesium has no charge and now has a charge. So in order to do that, like all metals, in order to become an ion, Mg2 plus, it lost 2 electrons. Oxidation is loss of electrons, so this would be oxidation. Oxidation. And for my ionic equation, I'm simply just going to combine the two half equations. So it will be Cu2 plus Mg. Remember, I don't need to include my electrons. Cu plus Mg2 plus. And that really clearly shows how the charges have changed in this reaction. If you didn't get that one right and you are now doubting yourself for 2 and 3, pause the video again and just try 2 and 3 again, using that method with writing the charges at the top. Another top tip is your number of electrons for oxidation reduction should be the same. So if that didn't work out for you, try it again, please. Right. If you're confident, then let's carry on. So let's put the charges above. So here we've got magnesium again, so this is 2 plus. Now iodine is in group 7, right? So an iodine ion, let's just zoom out a little bit. One iodine ion has a -1 charge, right? But because there's 2, it will be -1 times 2, which is -2. So the combined charge of the iodide ion in this case, not all cases, but in this case is -2 because we've got 2 of them. Right, sodium, no charge. Same thing again here, guys. Sodium's in group 1, it forms a +1 ion, but because there's 2 of them, the overall charge will be +2. And iodine again will have the same charge, that's our spectator ion, -2, and the magnesium has no charge. Right, so let's write these out. So let's start with the magnesium. So Mg2 plus, how did it become Mg with no charge? Right, so this ion is positive. In order to get rid of that positive charge, we need to add 2 negative charges, 2 electrons. So that gain of electrons is called reduction. So we would say that the magnesium ions have been reduced. Let's then look at sodium. So we've got sodium Na, we'll put 2 in front. So how do our sodium atoms become sodium ions? So we've got 2 Na plus. So each atom has lost 1 electron each, but because there's 2 atoms, in total we've lost 2 electrons, and so that is oxidation. And we're going to combine the two to write out our ionic equation, which will be Mg2 plus 2Na and Mg plus 2Na plus. That will be your ionic equation. Right, last one. I just realised I should have left a bit more space, but that's okay, we can work with that. So, same principle as the previous one. Overall, the chloride part of this formula will have a -3 or 3- charge because each chlorine has a -1 charge and there's 3 of them. Therefore, the ion will have a 3+ charge because these charges add up to 0. This has no charge. The aluminium has a 3+ charge, the chlorine has a 3- charge, and our iron has now got no charge. So we'll write these out, starting with the ion, that's a hard thing to say. We're going to have to add 3 electrons to make this charge add up to 0. +3 - 3 is 0. That's how we lose that charge. So iron gets its electrons back, so it gains those electrons back, the ion gets reduced. Okay, so that's reduction. Chlorine remains the same, that would be our spectator ion, but the aluminium, you can see, goes from having no charge to a 3+ charge. So aluminium, how does it do that? Right, aluminium, like all metals, has to lose its electrons to form a positive ion, and in this case it's lost 3 electrons. We call that oxidation. And you can see, guys, the number of electrons in each side is the same. So when I'm writing my ionic equation, just cancel these out. Fe3 plus Al, Fe plus Al3 plus. You can see, guys, that its charge, the charges that have changed. Okay, right. I'm going to just put this in a bit of more context for you by showing you an exam question that I've written out, and I want you to try, maybe give yourself 4 or 5 minutes. It is 4 marks. So the question is this. So you can see that they've given us an ionic equation. They've actually told us that the reaction was initially between zinc and iron sulfate, but they've not included sulfate because it's not needed when we're writing out the half equations, because its charge doesn't change. And it explains in terms of transfer of electrons which species, so which of the reactants is oxidized and which is reduced, and include half equations in your answer, and that's 4 marks. So you're essentially doing what we've done before, but working backwards. We use the half equations to write out the ionic equation. Now you're going to use the ionic equation to write the half equation. So just pause the video, give yourself about 5 minutes to do that, and then we'll go through it. Okay, right, let's start with zinc. So zinc has become Zn2+. We're going to think, how did it do that? So here, if it helps, picture the ion, like the dot and cross diagram, the diagrams that we're used to drawing to show charges with the square brackets, electrons in the outer shell. If that helps, picture that as you're writing out your half equation. So here we've got an atom, and clearly it's got 2 electrons. Its outer shell's lost 2 electrons in order to form a positive ion with that charge. So we can see that we have lost 2 electrons. Okay, so what we would say if we're writing out an answer in an exam, we would say something along the lines of zinc is oxidized as oxidation is loss of electrons. So I've identified, I've done the first bit, what's oxidized and reduced. I've included my half equations, and I've justified why it's oxidation. We do the same thing for the iron. So in this case, iron has a 2+ charge. In order to lose that charge, it would have had to gain 2 electrons and form Fe with no charge. Yeah? And so we're going to say that the Fe2+ ions are reduced as reduction is gain of electrons. And that would get you 4 marks. Well done if you've got that right.